basically fit in the.
We are going to come on this.
Sorry?
We are just humming on this.
So they're saying there are slides ahead, which will explain those. Anybody else? Any questions? Sir? Okay.
So now, Sam will take this one.
Next. Okay, so as Alok just told, just elaborated in the two examples of how quickly you can code in Node.js. So the key thing is over here that whatever you are writing it, first of all you need to think in terms of the events. So let's say, just try to prove it. Okay, so here what we have told is that create an HTTP server and then listen on to this port. Okay, on this address. What you actually need to do. So what the server does is that it basically waits for this event to happen. So that event is basically the occurrence of a request. So we need to think in terms of events, because most of the time when we talk about the non-blocking input/output and how does it affect us, so we want to get rid of that thing using the events only. So we need to think in terms of events, and apart from it, we need to think in terms of the callbacks, because what would happen when actually such an event is fired? So we need to register a callback that okay, when that event occurs, the callback will take care of it.
Just one more question.
Yeah, please.
So, how it is different from what we have in ext.js or let's say, because there also we have event-oriented mechanism where you can register a callback, and once the event is completed, the callbacks all are getting called. Same like the same visitor pattern, or let's say, sorry,
Your callback mechanism, the event loop pattern.
Yeah. So how it is much more, how it is different, or is it similar than what?
See, it is exactly similar.
Can you repeat a question? Repeat a question? Yeah. No, because you're not holding the mic, you're not able to hear that. Yeah.
So my question was how exactly this event callback mechanism is different than what we have in other framework like ext.js, because I just work on ext.js.
So it is no way different from it. The real thing is, it's all JavaScript. All those events which we used to handle in the browser side, those are coming onto the server side. So the key thing is, for a long time, the people who work on the browsers using JavaScript, so they are so used to thinking in events. For them, events is not a different thing. But for the people who used to work on the server side, for them everything is like an execution step. One by one, we'll go. We'll just have a look at an example that will highlight.
Okay, so one more question.
Sure.
Like we have 8 different methods in HTTP.
Correct.
So how many of it are supported by node.js HTTP server?
See, basically, it would support all of the methods.
So that means it is REST capable.
Definitely, this is REST capable. Apart from the REST capability, because REST is more or less a thinking paradigm. It's not a standard; it's a specification set. So we are having different. There is a framework over this for Express.js, which helps you write the REST-ish applications very easily, and it would provide you a lot more other capabilities like planning routes and all those things.
Thank you.
If you want to upload get the large file, then can we change it then to application like that?
Definitely. Means that is only the content type. What you are going to accept or whatever you are going to send it out. Which can be the you want to use it, definitely you can use it. Should we go ahead?
Yeah, let's go ahead. So
And one more thing is that we need to design our whole stuff using the closures and callbacks. Now, we are used to the JavaScript programmers are used to callbacks. We need to provide a callback for an AJAX request. We need to provide a callback on the click event, key press down. So the same things, the same capabilities we need to use on the server side while designing the pages. Okay, now there is an important question: the why Node.js? We have seen a lot of things happening here, over and there. We have learned how to program in Node.js, but what makes Node.js fundamentally different from our current server-side scripting languages? Could anyone tell me if anyone has seen any significant difference? Okay, let me ask it this way. Why would you care to learn another programming language? Or rather, why would you care to bring JavaScript to the server side?
First thing I would like to talk about using JavaScript or rather evented IO
I mean, event data is something important when it comes to server side, because unlike other servers, when the client sends a request, server receives the request and then starts processing it. For instance, say it's trying to read a 10 gig file, 10 megabits file, then it's blocking for that much time, which is not the case with event data. The main loop says somebody, okay, this is the task you have to do, which is reading the file, and this is the chunk of code that you have to execute after you finish reading the file.
Excellent.
So that is event data. So this rather prevents the server from blocking.
This is the fundamental aspect what we are looking forward to, because this event loop pattern that helps us get rid of all those wait states which normally are introduced with the other programming paradigms. This is the fundamental thing. Apart from it, why node.js is a better choice? So, would anyone tell me that why using JavaScript would help when we are going for this event-based things?
I think because in JavaScript you mostly work in the callback manner for each and every step.
Perfect.
Callbacks.
Yeah, definitely, because we need a programming paradigm where everything is based on events and callbacks. And as JavaScript is basically event oriented, it's having event mechanism in its core. It's not something which is extensively planned in it. And last thing is this is the general question: that is Node.js the next big hammer which is going to settle all our problems?
No.
Of course. Not yet.
We can say what after 10 years or 20 years what it will be.
Yes.
So the basic thing is it's not suitable for all kind of situations when we want to code in it, but definitely it is suitable for most of the places where you need to do a lot of data centric things and you need to wait for some other services to appear. And particularly it finds its using in the cloud, because in cloud everything is a service. You need to wait for it, and if that wait time increases, you cannot take up more responses. You cannot take more requests and responses. So we'll just take a look at it, how Node.js differs from
One question before we actually start deep into it. So I couldn't get much answer about it. Like as you have said, it's a single-threaded stuff. So how it handles? I mean, if it's a single thread, and when we say it's non-blocking. So I feel it's contradictory because somewhere you have to execute something, and again if it's a single thread, then every other thread is blocking.
Okay, so there is a big catch. So when I do say that it is single threaded, so it's single threaded only for handling the events. It's not single threaded for execution of those things, because when I do say that, let's say I am having a long CPU bound task associated, so definitely I need more threads. But what if I am managing those threads as an application developer? So it would be a big pain for me. So this is the case for normal languages which provides multi-processing or multi-threading paradigms to us. Because the real problem starts with that I need to manage the threads, and whenever the application developer starts managing the threads, it becomes a leaky abstraction and creates a lot of problems and it solves. So we'll just overlook it. Next slide. So this is our traditional architecture. Over here I am trying to highlight an Apache process. So how many of you have an experience of debugging applications on the server? By running the server. Okay. So the fundamental thing which you all know is that we need to run the process in one single thread, because in the debugging mode we need to run the server in single threaded mode, so that we can see that actually what is happening. Because there are multiple executions going on, we will not be able to focus on this. So normally what happens that let's consider a typical scenario. I am having a sort of application where whenever a user queries in, whenever a user sends a request, I make a query in database, and then on the basis of that query, I send a mail to the the requester, the person who requested over here, and then I just send back the response. Okay. So here, what happens that whenever I am trying to make a request to the server waits for those two services to respond back. First of all, it waits for the database server to be connected. Okay. Now, once I got a connection, then I would be making a query, and then again there is a wait state. Next to it, I need to send a mail, so I need to connect to the mail server, place my request over there, and again I will come back. So these are basically the two wait states where the thread is basically blocked. Now once the thread is blocked, so basically it would not respond to other requests, because it is already responding back to this particular request. Now the simple answer would be to have more threads. Why to live on one single thread? So that's the reason why the Apache is having lots of threads to be smart. But again, the real problem is a fundamental difference. Because fundamentally, even if all those threads are spawned in parallel and they are listening to the request, they would again be blocked on those wait states.
Yes, sir.
So here, this is the same thing which we highlighted in the diagram. So we are trying to connect to the DB, we are trying to select a schema, and we are trying to execute a query. So in all these three states, we need to wait. Now how we actually do wait is, I'd like to highlight it with a sort of an example. How many of you have booked a gas cylinder? Almost everyone. So what is the normal process we do? We just either place a call or we go over there and stand up in a queue. So what happens? We need to wait, or don't we? Definitely wait. We need to wait. There is another situation where some lucky day you might arrive on the reception desk and you will find that 3-4 executives are sitting and only anyone of them just answer to your call. So the real problem is the wastage of resources. Either you are being pushed to wait, or either the people over there you are unnecessarily deployed many people to look for the request. How this thing changes over here is we need to have a small piece of infrastructure. How it can be? This is something which is basically done by my gas agency over there. I don't own it. I'm surprised. So what they did is that they asked people to get register their mobile numbers. So once you have your cell phone number registered over there, you just give them a missed call. So what they would do is they would reply you back with an SMS. Now, once they are about to deliver your cylinder, let's say after 10 days, they are delivering a cylinder. On the particular delivery day, they will just give you a call back. That okay, today we are going to deliver a cylinder. Please be ready to pick it up at your home. So the real advantage is you don't need many such executives. All you need to do is a small piece of infrastructure which lets the people over there know that something is in the queue and they need to process it one by one. So essentially it goes single threaded. We can just imagine it in that fashion. So isn't it a nice piece to have that small piece of infrastructure?
A lot of people lost their jobs.
We will have them work at the infrastructure field. That's a good point.
More gas.
More gas against you.
No problem.
So with every IO call, he either blocks the entire process unless the call is completed, or even if you are going for multi-threaded mechanism, that implies the use of multiple execution stacks. So basically you need, in any case you need more resources. So either you wait or you get more resources. But effectively the fundamental problem remains the same. This is how the event-based non-blocking IO works. So over here what happens is that whenever a client connects to a node's HTTP server, so the node's event loop, which is mono-threaded in nature, it responds back. And how does it actually respond back is that basically it registers the call. So what we saw over there in the HTTP server example, that whenever you receive a request, you execute that function with two arguments. One is request and another is response. And the same thing happens over here. The node's event, which is event loop, which is mono-threaded, it registers your callback over here, and basically it delegates those long-running operations or whatever data-centric applications you want to build, whatever you want to do, to the node.js platform, which is basically a wrapper around the Google's wait engine, and it is pretty fast. So basically the long operations are deferred to the worker threads, and these threads are internally managed by the node. We need not worry about them. So we are all, although we are having multi-processing capabilities, multi-threading capabilities, but they are all hidden perfectly under the abstraction, and we need to code our application in a in a single threaded style, and we need not worry about those leaky threading abstractions and all those things. And whenever this, yeah, please.
How does the event loop handle by the node.js?
Okay, so I'll just, if you could just recollect the first example which Alok has shown, that is the first line which you wrote. So basically you wrote that set timeout. You called a set timeout function. Okay. So what happened? That set timeout function tells node.js to exit the event loop after 2000 milliseconds, and then execute a function and then exit. Okay. Now, when we ran the server example, we never set a timeout. So the node.js was running indefinitely. What happens then whenever you start any application with node.js, the event loop, which is mono-threaded, it starts up and it starts pulling from the queue where you actually register the events. Now, how it happens is, I won't go very much deeper in it, but I will give you the higher level abstractions. So eventually, what happens is whenever you call a function, so basically what you do is you specify an event, that on what event you are interested in listening. Okay, you provide a callback. So what it does is it registers the callbacks in its queue, and it starts listening for the event using the pool mechanism. Okay. Once that event occurs, what it does is, let's say there are multiple events being occurring over here and there. So what it does is it pulls one by one out from the queue and it starts executing those callbacks. So in this way, your request gets resumed from the state from where it was started, when it was registered. So eventually, what happens is the thread which is processing your request, it basically is freed of just stacking up at this particular point, because that thread could handle many requests in parallel. Okay, so that way you scale out. You got it? So the same example of the DB server what we wrote earlier in the normal style, we have written it in a non-blogging iOS style. So here, over here, what I am trying to do is, I am trying to say is that connect to a DB, I am providing my configurations, and I am registering a God server event. So basically, this God server is nothing but a function. It's a callback I am providing, and in the argument what I have given is the DB server. So what I do say is callback when a server object is received. So whenever you receive the DB server object, then your God server method would be called. Okay.
Sir, we just clarify that this is a pseudocode, right?
Okay. Yeah. Okay, that was a real catch over here. Because there is no way a Node.js code. It's just a pseudocode to highlight two things. We will dive into the So, the moment I get a DB server object, I will call a select schema method. So in the select schema method, what I am doing is I am trying to listen for the database. Please connect me to this database, and once that DB schema object is available, I will call the God schema method. And whenever this God schema method will be fired, so on the occurrence of this DB schema object, then I will call the DB schema dot query method. And in this, finally, I am using the God result method. So actually, when your result would arrive, then only it would be appearing out. So in this way, you scale out, because you need not wait over that particular point. So your thread could listen to multiple requests in parallel. This is a detailed example. So all it does is basically it is again the same example, a sort of a HTTP server we will be running out, and it is based on a REST style. So it would you just provide the directory name over there, and whatever files are in that directory, so those will be listed up. Hello?
Yeah. And this is an actual code, right?
Yeah. So I just highlight this one. So over here I am having two directories with me by our names, Hussain and Alok. So if you just look into this, so there is one file in Alok directory, the other file is in there is one more file over here. So what all this small script does is basically it lists up all the files present in the directory. So when I do say list the contents of Alok, it will list up the contents of Alok directory. So this is basically a small REST example which we have built over here. So the essential point is that you can code using you can code your REST web services pretty easily using node.js. The infrastructure piece is so little that you don't get bogged up by those intrinsic details of the framework and all those things. Coming back to the code. Okay, so here is a detailed example. What we are trying to do is we are we are requiring two modules over here. The first is the file system, which is represented by FS, and next is the Express. So Express is basically a web framework for developing web applications with Node.js. It provides you all those facilities to route your calls, to register to the various ports and all those things, and even harnessing the templating style and all those things. What we do over here is basically we are just requiring those two modules. We prepare the object of Express and we start listening to the port 3000. Next to it, what we do is we read from a directory, that's the current directory, and we are printing the length of the files over here. So it's just a simple call. Next is a real call when you say that app.get. So over here what you do is you listen to the 3000 port on the get protocol and on this particular URL. So this particular URL would be the file index and then the user. So this colon user is basically a parameter. So you can change that parameter. So what I did was I gave different arguments to the parameter and our names, which are basically the names of the those directories present on the server. All it did was whenever it received a call, it listened for the it prepared the response. So all it did was it read from the request the parameters, the user parameter, and then it started reading from this directory, the user directory which we provided. And once it got the files, you can see that over here, this read directory and then function error function which is having two arguments. One is error and another is the files. So basically, once this directory read operation is finished, then it calls that particular function, the error and files. So if any error has occurred, we are having that code. Otherwise, if everything goes well, what we do is we set the response to content type text HTML. Okay. Next is we just prepare in a scripting fashion. We just prepared a line of dynamic HTML, and later on, whatever file number, how many files are there, so we just looped in over that particular file array, and we just wrote in a tabular fashion. So it's a very primitive example. Let it highlights two things: that we could code REST-based web services pretty easily using Node.js, and we are having good frameworks to support all those things. The handling of requests in a REST manner, or be it an MVC style if you want to go about it, and apart from it to handle the file system and things and all those things. Now Alok would tell you more about what this
question. So the IP address there was there, and app.json can explicitly.
Okay, so the second argument to the lesson, if you could explicitly provide it, so that would be the host name. We can configure it.
Can you just talk a bit about what did you do to install Express? Because in Java, we include jar in the class path.
Hey, we need to take a break in about 5 minutes. So if we can have questions now, or we can break right away. If you're going to get into something detailed.
Definitely. If
we'll take a 10-15 minute break or some refreshments, and then we'll continue.
Response.site, it was before the response.write. It is difference between Express and HTTP.
Yeah, definitely. It's a difference. Because HTTP provides you with crude method of writing the things. But over here, the express.js provides you a fine print and
Very, I don't know, it's not like.
I want to add to this. I want to add to response.write and response.send. I've been exploring a lot about Node.js these days. The response.send sends at a stroke. You cannot send any header or any data after you send it once. Response.write is you can do it multiple times. Right? First JSON, second JSON, anything.
So it's used in server-side events mentioned.
Yeah.
So basically, I would like to add more to it, this thing, because you cannot call it response.send twice.
That's what he said. He said the same thing.
Yeah.
And he said, right, you can call multiple.
Yeah, you can-
It's like workflow.
You can write properly.
Okay. So, can I ask you a question? How much time would it take to take this example completely?
The example is already done.
Already done.
Yes.
So, I just want to ask you, do you want to continue on some topic or should we will take a break?
We can have a break and afterwards we'll talk about some of the technical topics like open source.
Okay, guys. So let's have a 50 minutes break. Okay. We'll come back over here in 50 minutes time exactly. So you can continue.
Yes, I'm